Today, we will learn how to solve a real world problem using machine learning with Python. We will learn how to build a model that can learn and predict. So, let's get into action. It involves various steps. First, import the data. Now, data often comes in form of CSV file. We have database with lots of data, so we can simply export that data and store it in a CSV file. Second, clean the data. That is removing the duplicated and irrelevant data, because model will learn bad patterns in the data and it will produce wrong result. Third, split the data into training and test sets. So now, after cleaning, we will split it into two segments, one for training the model and other for testing it to make sure that the model predicts right result. Like for example, we have 1,000 pictures of cats and dogs. So we'll result 80% for training and other 20% for testing. Next is we have to create a model. This involves selecting an algorithm to analyze the data. Now, there are many machine learning algorithms like decision tree, neural networks, and so on. Now, each algorithms have their pros and cons, level of accuracy, and performance. Now, algorithm you should choose depending upon the problem that you are trying to solve and the input data. So we and the best part is we don't have to explicitly, program an algorithm. There are different libraries available which provide these algorithms. Okay. Next is train the model. So we are going to feed it with training data. Our model will then look into patterns of data. So next we can ask it to make predictions. Okay, that is the next step. Like for example, cats and dogs. So we can ask the model to predict whether it is a cat or a dog, right? Now, predictions is not always accurate. So what we need to do, we need to evaluate and improve. Okay, now let us talk about libraries. Okay, now first is NumPy. This library provides multi-dimensional array. It is a very popular library. Then you have Pandas. It is data analysis library. It provides a concept called data frame. Okay, it is a two-dimensional data structure which is similar to your Excel spreadsheet. Okay, so we have rows and column where we can select the data. Then we have matplotlib. It is a two-dimensional plotting library for creating graphs and plots. Then you have scikit-learn. It is the most popular library that provides algorithms like decision trees, neural networks, and all. Okay. Now we are going to talk about code editors and data sets. Right. So there are different editors which we can use. We can use VS Code editor, but it is, really not the ideal one for data analysis. Then you have Jupyter, which you can install on your system by installing Anaconda on your system. But the best one in today's time is your Google Colab notebook, which you can directly use online. You don't have to install it, and this is the notebook which most of the data scientists use in today time for doing data analysis. Okay, now next part we are talking about data sets. So we can download the data set from a very popular website called as kaggle.com. It has data set for different data science projects. Okay, but for today I'll be using data set which I have created myself. It is just a basic CSV file. It has just some random data. They are not the real ones. Okay, so let's code today. So we are going to work on a real machine learning project. Okay, so imagine we have an online music store. So whenever user signs up, it will ask for age, gender, and based on their profile, we will recommend them different music album which they would likely to buy. Okay, so we are going to build model. We feed this model with sample data based on existing users. Our model will learn the patterns in a data, so we can ask for it to make the predictions. Okay, so we are going to work on this ML project, and as I told you, for today's class I have created the CSV file. So you can see it has three columns. You have age, you have gender, and you have genre. Gender has two values, 1 and 0. 1 is representing male and 0 is representing female. Okay, now here you can see I have taken few assumptions like males between age 20 to 25, they like hip hop music, 26 to 30, they like jazz, 31 above, they are liking classical. For women also, I have done the assumption like if they are between the age of 20 to 25, they like dance music. If they are 26 to 30, they like acoustic. And from 31 to 35, they are liking classical. Okay. So now let us start working on the Google Colab notebook. Now this is Google Colab notebook. I've logged in. We are going to work on this. Now first step, I'm going to import the CSV file. So just first observe the code and then I will explain it to you. Import files. Now when this is the run button, when I'll run the code, you will see this code will upload the file, and it will give me the option to choose the file from my system. So it will take little time to run. This is the file. So you can see it has uploaded it. Now we need to read this CSV file. So I'm going to write another code. I'm going to import the library pandas as PD, and then I'm going to read this CSV. And I'm going to store it in a variable. You can give any name to the variable. Okay, and now it is going to read it for me. Now this is returning a data frame which is two-dimensional array. Okay. Now what is the next step? Is to clean and prepare the data. Now in this data set, any cleaning is not required. Okay. So this data set should be split into two separate data sets. One first data set will be first two columns, which will become our input data set, and another which will become our last column, and it will be referring as output data set. So when we will train our model, we will give it two separate data sets. So the output set is nothing, it is containing the genre column, and it will contain the predictions. So suppose if we have a user that is 20 years old and is male, so what does it is showing? A 20-year male is liking hip hop music. So once we train our model, then we will give it a new input set. Like for example, we have a new user who is 21-year-old and is male. What is the type of genre music which this user will probably like? Now you can see here we don't have that row for 21-year-old male. So we are going to ask our model to predict that. Okay, and that is the reason we are going to split the data set into two separate sets. Okay, now over here we have a method called as drop. Now when I keep my cursor here, you can see this is the signature of this method, and it is showing different parameters with this method as, and I'm going to use the parameter called as columns. Okay, now by default columns value is none, but this parameter, what we are going to do, we are going to define the column which we want to remove, and that is our genre column. Okay, so I will write columns. Okay, and then I am going to put a naming convention here and name it as X. This will be my input data set. So you can see over here, it is just showing me the two columns. Okay, the genre column has got removed. Now what I will do? Now I want the other column, the last column, that is the genre column. So again, what I will do is music data. Okay, in the brackets. Oh, sorry, not these brackets, square brackets. And here I'm going to store it in variable y, and by convention for the output data set we use lowercase. Okay, now you can see this new data set. Yeah, this is your genre column. Now we are going to use algorithm called as decision tree, and we have a library called as scikit-learn, which we will take help of. Okay, so here on the top I'm going to import that library. Yes, so sklearn dot tree import. See, this auto mode is there, which is very helpful. You can take help of this. Yes, now so this sklearn is the package that comes with scikit-learn library. In this package we have a module called as tree, right? And we have a class called as decision tree classifier. Now what we have to do, we have to create a new instance of this class. Okay, so what we are going to do is we are going to create an object for this class. Okay, and we are going to name it as model. this auto mode is there. So we'll take help of this. This is always very helpful. We can take a help of this. And now we have a model. So next what we are going to do, we are going to train it. Okay. So that it can learn the pattern in the data. So model dot fit method. And what I am going to train it with two parameters, X and Y. What is my X? It is my input data set, and Y is my output data set. Okay. Now this is done. Yeah. Finally, we need to ask the model to make the prediction. So we can ask it like, what kind of a music does a 21-year-old may like? Okay. So model dot predict. This is the function which is going to help us to do the prediction. Now, this method will again take two-dimensional arrays. So arrays, we are going to use square brackets. Okay. And an array can hold multiple arrays. So first, I'm going to give two sets to it. One is for male and one I'm going to put it for the female. So you can see over here 21 male and 22 is the female. So we are asking our model to make two predictions at the same time. Okay. And we will store the result again in a variable, and we can give any names. Suppose I'm giving the name over here as predictions. So you can see it has done the prediction hip hop and dance. So hip hop is for the male and dance is for the female. Okay. Yeah. Now what we have to do, we have to calculate the accuracy of a model. Now in order to do so, we again have to split a data set into two sets, one for training and one for testing. Because right now if you see here line number 9, what we have done, we have given X and Y. X is my training and Y is my test. The second data set, basically both are, I have given it for training, right? So entire data set I have given for the training, and then we are using only two samples over here on line number 10. Only two samples we are using for doing the prediction. Now that is not sufficient. So general rule says, we need to allocate 70 to 80% of data for training and other 20 to 30% for testing. So then instead of passing only these two samples, what we are going to do, we can pass the data set we have for testing, and we'll get the predictions then. Okay. And then what we can do, we can do the predictions with the help of your actual values in the test set. Okay. So we can calculate the accuracy, and for that we are again going to import some library on the top. So let us do that from sklearn dot model underscore selection. Now see here, code indentation in Python is very important. Unnecessary gaps will not be allowed. It will give you a error kind of a thing which you need to correct. Okay. So what I'm doing over here, you can see I've imported this library. With this, we can easily split a data set into two sets for training and testing. Okay. Now let us do it over here. We are going to use this function which we have imported. Okay. And it will take three parameters: X, that is my first data set, Y, that is my third data set. And see what I'm writing here is test size equal to 0.2. Now, what is this third argument? It is the keyword argument, okay, that specify our test data set. So what we are doing, we are allocating 0.2 means 20% of our data for testing. Okay, so this function will return what? It will return a tuple. So we are going to put it in a packets. Now what are the packets name? Xtrain, xtest, y test. Okay. So here the first two variables which you see, xtrain and xtest, they are for the training and testing, and the other is for the output set. The starting two, one is for the training set, the other two, y test and y train, are for the output test. Okay. Now we are going to train our model. So instead of passing, the entire data set over here, line number 11, we have earlier passed the entire data set X and Y. Now what we will do, we'll just pass X train and Y train. Okay, and here for the testing purpose, what I'm going to do is I'm going to use my X test. All right. Yeah. So we get the predictions. Now what we have to do, we have to calculate the accuracy. So we simply, what we have to do for the accuracy, we have to compare the predictions. These predictions we have to compare with the actual values. That is our Y test. That is the output set for the testing. Now for that, again on the top, what we are going to do, we are again going to import one library. Yeah. So as the name suggests, import accuracy score from this particular library. Yeah. Now what it will do, it will help us to calculate the accuracy, right? So here at the end, now I'm going to use this function which will calculate the accuracy for me. So it is taking two arguments, you can see. Yes. Now these two arguments, first is Y test. It is containing the expected values, and this prediction, what it is containing is the actual values. So this function returns accuracy score. Okay. Now again we are going to store it in a variable. Suppose I am storing it in a variable called as score. Let us run. Now see, the value is 1.0. So this function returns accuracy score always between 0 to 1. So 1.0, that means 100%. Now suppose if you run it more times, you will see a different value. Because every time when we split a data set, it will have different data set, right? Because this function is randomly picking the data for training and testing. Now let us change the test size and see. Instead of 0.2, I am giving it as 0.8. Let's see what happens. Now see, the score is reduced to 0.2. So accuracy is dropped. Now this is really bad. Yeah. Now the reason is happening here is because we are using very little data for training purpose. So we should always keep it in mind to give more data for training. Okay. So make sure your data test size should always be 0.2 or 0.3, like that. Okay. So we should always train our model with huge data sets of thousands and more number of rows and columns. Okay. Hope you enjoyed today's video.